Let us start fifth unit where we will be studying about transmission lines. In the previous units we have studied about in the first unit we have studied about electrostatic fields, second unit magnetostatic fields, and in the third unit time varying electromagnetic fields. Fourth unit the propagation of electromagnetic waves, and in this unit the medium which is required for propagation of electromagnetic wave from one place to another place, that is the transmission lines. We know that energy can be transmitted either by radiating electromagnetic waves into air as in radio and TV, or it can be moved through a conducting arrangement known as transmission line. Therefore transmission line is a conductive method of guiding electrical energy from one place to another place. Basically, transmission lines are used to link between antenna and the transmitter or receiver. There are different types of transmission lines: parallel wire type, coaxial cable, waveguides, fiber optic cables. Parallel wire transmission is an open wire line. Examples for this are telephone lines and power transmission lines. In this, frequencies up to 100 MHz can be transmitted. To transmit signals whose frequency is more than 100 MHz, we go for coaxial cable transmission line, in which transmission is possible till 1 GHz. Above 1 GHz signals, if we want to transmit, we use waveguides. In this, transmission is possible in UHF range. Further, if we want to transmit the signals whose frequencies are more than UHF range, we use fiber optic cables, which have got many advantages. Now let us study the primary constants of or primary elements of transmission lines. To understand or to design a transmission line, it is necessary to know the electrical parameters that are associated with the transmission line. If a parallel wire carry current I, then magnetic field will be generated around that wire, and voltage is developed along the line. Due to magnetic field and current, there will be series inductance L. Due to voltage along the line, there will be a series resistance R. When we apply voltage between conductors, electric field will be generated. Due to this, there will be a shunt capacitance C and shunt conductance G. Therefore, a unit of transmission line can be represented with these primary constants as shown. The primary elements are distributed along the transmission line uniformly, hence the name uniform transmission line, where R is the loop resistance per unit length, the sum of resistances of both the conductors per unit length. Unit for loop resistance is ohms per kilometer. L is the loop inductance per unit length, that is, it is sum of the inductance of both the wires per unit length. Unit for L is Henry per kilometer. C is the shunt capacitance between the conductors per unit length. Unit for C is farads per kilometer. G is the shunt conductance between the wires per unit length. Unit for G is mho per kilometer. The series impedance of transmission line is Z equal to R plus J omega L, and shunt admittance Y equal to G plus J omega C.